Hi all, welcome to Network Path. Let's see how distance vector routing really works in action in this video. Imagine there are four routers A, B, C, and D, all starting up at the same time, right? At the very beginning, time t equals to 0, each router only knows about its directly connected networks. In their routing tables, those networks are listed with hop count 0 and no next hop router because they know they are directly connected. Each router then broadcasts this information to its neighbors in the next cycle. Okay, so router A hears from router B at time t equals to 1. And what it hears from B, B says, I can reach networks 1 10.1.2.0 and 10.1.3.0 both 0 hops away. You can see if you look at router B, you can clearly see that these are two directly connected networks. That is why it is saying that both 0 hops away. And A thinks that, well, if B can reach them in 0 hops, then for me, they are 1 hop away, right? If you look, if B is telling that 3.0 is 1 hop away, is 0 hop away, then A at least needs 1 hop traveling to reach this networks, right? And it is saying that 2.0 is also 0 hops away and it is directly connected. But what A does, A check its routing table. It already knows that 2.0 is directly connected, so it ignores B version because 0 hops is better than 1. And if it adds, in case if it adds the B's version, then it will be a wrong route, right? So 2.0, which is directly connected to A will update it as 2.0 via B and one hop count away, and that will be a wrong information. That is why it ignores it and keeps the directly connected route. But 3.0 is now new, so A adds it and it says that it is reachable via B and it is 1 hop away. But it does not write it is reachable via B, but actually writes about how it is reaching, what interface, what is the next hop IP address. So you can see that the to reach 10.1.3.0 for A, it has to send the traffic to 10.1.2.2, which is this interface, right? And this 3.0 is 1 hop away. And at the same point of time, router C, you can see router C has received updates from this side and this side as well. So it gets to know about 3.4.0, 3.0 and 4.0 from its adjacent routers, but it knows that they are directly connected. So it will ignore those routes and take those which are not present or maybe which are more optimal. Correct? So this happens at time t equals to 1. Now at time t2, another update cycle happens. Router B sends its latest table. A again increments the hop count by 1 and compares. Okay, so every time a cycle is starting, the router will send an update to its adjacent routers by sharing their routing table, not just directly connected routes, but the old updated routing table in the last update timer. And this is how A will get to know that 3.0 and 4.0 are reachable via 2.2, but they are at different distances, right? So 3.0 is 1 hop away and 4.0 is 2 hop away, right? And this is how these routers are exchanging information, and at time t equals to 3, full routing information is exchanged, right? So all the routers are now aware about all the routes and networks that are there inside there in the infrastructure. Okay, so after a few rounds, the network will get converged. So this is known as converging the network. And if there is some problem with this link, let's say 4.0, they will again exchange the information with each other. And after some time or some update cycle, all the networks will get to know that this link or this network is not reachable, and they will update their routing tables and they will be fully converged. Okay, and with that, I have an analogy for you guys. Think of it like being lost in Paris. Okay, you want to find the Eiffel Tower. You come to a street corner and see a sign. Eiffel Tower is on the right and it is 3 kilometers away. You don't know what the streets are like because you are new to that place. You don't know whether there's a lot of traffic or it is a faster shortcut. You only know that the direction is there, that is right, and the distance is 3 kilometers. That's exactly what distance vector provides information about, different routes, a direction and a distance. Not route, sorry, networks, a direction and a distance, but no details about the path itself. We don't know what terrain we have to go through. And just like in this case, if someone by mistake or by mischievously turn the sign around, you'd walk to the wrong way. Distance vector protocols are vulnerable in the same way. They trust the information they are given, even if it is wrong. So it is vulnerable because an attacker can attach its router to the infrastructure, and it will try to advertise, it will try to share routes which does not exist, or maybe they provide wrong metric values, or maybe they are directing it to a black hole. So this is one of the vulnerabilities, and that is why we have sort of authentication process in every routing protocol. So distance vector routing is basically routing by rumor. You must have understood by this example. Routers spread what they know, hop by hop, and they believe because they have no other choices, like travelers passing along the directions in city. It's simple, but it can also be misleading if the information is not accurate. Right? I hope you understood the process through which we go in a distance vector routing, how the basic route and network sharing is done. If you have any doubt, you can comment down, and I'll meet you in the next video. Thank you so much.